Okay, welcome to Forensic Investigations. It's a presentation on images and how hashing is used in images. So what I'd like to do is talk a little bit about illegal image, talk about explicit image detection techniques that are used. I'd like to talk about a technique called fuzzy hashing. I'd like you to talk you through the National Software Reference Library, the reference dataset hash database, and then we'll talk a little bit about the EXIF file format. Now, let me just go up one. What are illegal images? So I have some slides here talking through some of the legislation that has been written that's most associated with illegal images. So we have the extreme pornography, where according to the Criminal Justice and Immigration Act of 2008, it's an offence for a person to be in possession of an extreme pornographic image. And its definition of this is something that is grossly offensive, disgusting, or otherwise obscene in character, and an act which threatens a person's life, an act which results in or is likely to result in serious injury to a person's anus, breasts, or genitals, an act which involves sexual interference with a human corpse, or an act to perform, or a person performing an act of intercourse or oral sex with an animal, whether dead or alive. So these, it is an offence for a person to be in possession of images of this type. Now, we also have child pornography, which is legislated in the Protection of Children Act 1978, where it is indecent images of someone under the age of 18, and it is illegal to take or make any indecent photograph or pseudo-photograph of a child, to show or distribute such photographs, to possess these images with an intent to show or distribute them, or to advertise for showing or distributing such photographs. Now, this making offence includes downloading them, causing them to be displayed on the screen, and printing them. So obviously we're able to look for images that are either extreme or illegal according to these definitions. And if they happen to be located on a computer system, then they are deemed to have been in the possession of that person. There is some defence for 16 and 17-year-olds because, of course, it is possible to get married at the age of 16 and to procreate at the age of 16. So if a defendant is married or an enduring family relationship, having lived together, and the picture only includes the child, as in the 16 or 17-year-old, and the defendant only. Now, how is it possible to identify an image that is pornographic? And this is a question that people have been thinking about for quite a long time now. It's an active area of research. There isn't very much maturity in it, and there isn't very much maturity in it because it's really quite a complicated and contextual thing that humans are able to understand quite easily, and computers aren't. Most computer techniques rely on skin tone content, which aren't necessarily, or is not necessarily, the best technique. Methods also match from databases of known illegal images, and those are very easy things to do, to match an image which is exactly the same as an image that is known to be illegal. The problem is attempting to automatically identify pornographic images or illegal images is it's very, very unreliable. There is too much contextual information that is required, and it's very difficult to distinguish between types of images that may well fall into the illegal or extreme categories. However, FTK has an example plugin that allows you to, or that scores images from 0 to 100 on the potential to be pornographic. So maybe you have a large number of images and this will reduce the number of images that you need to look at in order to identify ones that could be pornographic. We're also able to do something called MD5 hashing, so we can take a hash value of image files. And the problem with this, of course, is that you're able to change an image file, have a completely different hash as is being shown here. We have two images that look absolutely identical, but the hash values are different because there is something different about these two images. So attempting to identify illegal images based on their MD5 hash, it does work as long as nothing has happened to the image. If you have made any change at all to the image, you will end up with a different MD5 hash and you're not going to get an exact match. So that technique is, well, it's good. I think it's worthwhile, certainly worthwhile doing, but being able to identify the fact that two images are the same, or being able to identify the fact that this image is illegal, is much more important technology to develop. Now, when it comes to the MD5 hashing, there is the National Software Reference Library. This is the US sponsored, it's a part of NIST again, and the National Software Reference Library actually manages the reference data set, which is a set of hashes describing known traceable software applications and also known images. Now, the reference library itself is actually a set of physical media, downloaded files, etc. It isn't just this large database of of hashes associated with illegal images. But it's important for you to know that this exists, so that you have an idea that it is there. Now, if we go back to our nice penguin, we can see that even though the penguin looks the same, something has changed. Now, we can use a technique called fuzzy hashing, which will tolerate some differences between files. And so it isn't a binary yes or no, these two hashes are identical. You're able to take a hash of part of the file and then match those parts of the files together. So it allows you to make comparisons of hashes and give an indication of the similarity between two files. So if there's some document that's been altered, or part of the image has been altered, then you're able to match part of the file. If all of the file isn't there, you're able to match again on part of that file. So it's quite important technology to develop. Here's an example of how it works. We're able to split the file into chunks of whatever size. We can take hashes of those chunks and then perform matches of those hashes. And so an example that we have below, there's two bullet points. One says a quick brown fox jumped over the lazy dog. How much would could? And the one underneath it says the quick brown fox jumped over the lazy dog. How much could good could? And you can see that there are two character changes that are made between these two sentences. These two statements, and those two character changes, in fact, I mean only one is required, will generate completely different hashes. But if you were to hash the quick brown, that's exactly the same between the two statements, and then jumped over the lazy dog, how much, and that's exactly the same as well. So you're able to have an idea about the similarity between the two files and accommodate for slight differences between them. Now, there's also a little bit about byte alignment. So how do we deal with the quick brown fox jumped over the lazy dog, how much would could, if a part of the file has been increased? So instead of matching, as we would do here, byte by byte, the quick brown fox, etc., and then we can match byte by byte. On the second example, we can match the quick brown fox byte by byte, but then after that, over is matched to the U here, instead of being matched to over here. So we have this input into the file, which means that we would be able to have a match. However, the byte alignment between the two files, in this case the two statements, are not aligned after the change has been made. Now, it is possible to perform this piecewise move between the two files, so you're able to attempt to match piecewise hashes. And that may well enable you to accommodate for or account for additional input into one of the files to say that yes, the file is very, very similar, and all that's happened is that there's been some slight changes that have moved or caused bytes to be misaligned. So we can accommodate for any misalignment in bytes. Now, I need you to prepare yourself because I'm about to show an explicit image. And here is an image which is explicit. So here we have something which, depending on how you are able to identify what an explicit image is, this you might identify as being an explicit image. Now, how do we match this image on the left to this image on the right? So we can see, well, we've got some contrast changes here. We've got some of this data being split and moved. So we can see as a human, well, do you know what? I think that these two images are exactly the same. I'm able to pull out some features from the image that allows me to make that statement. And the features that I'm pulling out are the fact that I can quite easily say, well, the subject of this image is more than likely going to be the cat because of the way that the camera is angled at it, because of the way that the cat is positioned in the picture, rather than whatever these things are, these rugs underneath. And so in the same way, I'm saying, okay, let's try and match the cat. I can match the facial position, I can match the eyes and nose, I can match the way the legs are, how the tail is, I can match the coloring here. Yeah, they look pretty similar. Would I be able to take a fuzzy hash of this little section here and match it to the little section over here? Probably not very well as we go through, because of the color change that's taken place. The actual information that is encoded in this image is going to be very, very different. The image has moved, so we're bytes lined out. As well as that, the values of this image have also changed. However, if we do something like this, well, now we only have byte alignment. We don't have a change in the image. We've lost some of it, so we've got some of the image being truncated, but now we have the ability in a much better way to perform some fuzzy matching. So I can match this small square over here to this square over here. And in this case, well, this is very interesting, isn't it? Because I now have a picture which, okay, I can say, yeah, do you know what? I think it is exactly the same image, but actually it's just been rotated slightly. Or it's a different image of the cat. Sorry, my apologies. And so in this case, well, it looks like exactly the same cat. It looks like it should be the same image, but it isn't. Unless Gareth actually only just rotated the head, but these do look like two different images. They are two different images, but of the same cat. So will fuzzy hashing match these? Well, I don't think so. They're not of the same image. So what have I just done? I've just given you a demonstration. Well, humans are quite good at spotting similarity. I mean, you can physically sit there and say, are these images the same? Are they not? Humans aren't very good at spotting what data is identical. And that's sort of evidenced here. These two images look exactly the same, but when you begin to look at them, they're not. Computers, however, are very good at spotting data which is identical. Fuzzy hatching won't match these. We're unable to do that well. The creases on the carpet, maybe. But computers are bad at spotting sort of very contextual things. They're bad at spotting which data is similar. And it's that difficulty in being able to put bounds on what is known as being similar. That is a thing that we still need to overcome now for an automated process to identify illegal images. Now, there is some work that's been done on this. There's something called a context-based image search. It is still in its infancy. It does hold a lot of promise for forensics. And the idea is, as I was just speaking about, we're able to identify features. We're able to select which features we want to extract. We're able to extract those features and then perform some form of comparison on those features. There's a nice little bit of software that's been produced that does this called ImageSeek. You can download and use this yourself. But it gives, as you can see here, the ability to draw something which is then matched to a certain number of images. And as you can see, this drawing isn't particularly good, but it has matched consistently a number of buses. Now, frankly, if you were to say, if you were to hide this panel here and say, what does this look like? I have no idea what I'd say. However, if you were to give me this and then say, can you match this against this database and include these images plus lots of other images, I would probably say that these are similar, maybe even with the same percentages. And that leads me on to the last thing that I wanted to talk about in this presentation, which is one of the things you're looking at in the lab. Oh, sorry, it doesn't. I have another example here of ImageSeek. Just something similar for finding similar teddies, which is, I mean, it's amazing what we end up with. 40%. Well, ice cream cones, a teapot. This is just odd. How on earth does that look like a teddy bear? I don't know. But I'm going to ask you to identify EXIF information, which is the exchangeable image file format from images. Now, EXIF is a set of metadata which is attached to images by cameras or by software, however the picture's been taken. It may well add a date and time, anything to do with the camera, the settings, shutter speed, focal length, etc. It may well add a thumbnail, descriptions, copyright information, GPS location as well is also a possibility. Now, for those of you who did digital forensics last year, we did have a look at this. We did some very simple things in EXIF. If you right click on Windows, Linux, etc., you can have a look at properties. You get only a small subset, but you can either manually extract this information or you can use some tools, and the one that I recommend using is a tool called EXIF tool. Now, sorry, this is just continuing to say that cameras can also give GPS information as well, to give an idea about where those photographs were taken. So here is an example of a JPEG image, and this JPEG image, if you look at the EXIF file format, you're able to get some information about the camera manufacturer. So this is Samsung. This looks like it's actually a Samsung phone. Get an idea about what the focal length is, exposure time, information, which is, well, it ties the photograph to the device or to the type of device. Interestingly, we also have GPS information here, even though you could probably guess what the GPS location was to quite closely. We have some information about when this was taken, and then further information about the image itself. So the information that's stored in the EXIF file format is very useful from a forensics point of view, and I hope you do get a lot from it. So in conclusion, if you do move into law enforcement, sadly you may have to handle a lot of child pornography or illegal pornography. This technique of fuzzy hashing, I think it's important that you know it can overcome some weaknesses, but it still doesn't do a very good job of being able to tell what files are similar. There is a database that is produced by NIST, and a part of NIST called the National Software Reference Library, the reference data set, that can be used in order to match MD5s of known images. EXIF data is incredibly useful, and interestingly, if you do happen to find one image, you may well find more, but you don't need to necessarily find all. Thank you very much.